Write 31% as a fraction. So any percentage is a fraction out of 100. So I can write this as 31 over 100. And in some cases when you do this, you might be able to simplify the fraction. But in this case we can't, this is the simplest form. So 31 divided by 100 is the final answer for 1 mark. We want to change 3 meters into centimeters. Now what you might know is that 1 meter equals 100 centimeters. And I'm going to treat this a little bit like an equation. And I'm going to multiply this side by 3, giving me 3 meters. But because I've done it to the left hand side, I'm going to do it to the right hand side too. So multiplying that by 3, we get 300 centimeters. So it now says that 3 meters is 300 centimeters, which is what we want to work out. The answer is 300 centimeters for 1 mark. Write the following numbers in order of size, starting with the smallest number. So these are the 4 numbers that we want to write in order. And I'm actually going to write them out as a vertical list, and you'll see why in a second. So what I've done is I've written them out in a list like this, in no particular order. However, I've lined up the decimal points here. Now I'm going to work from left to right, looking for the smallest number, and you'll see what I mean. So firstly, in this left-hand column here, what's the smallest number? Well, that's 0. Okay, so the smallest number must be this number or this number. Now let's move on to the second column. What's the smallest number in the second column out of the 2 numbers that we filtered in from the last round? So 0.12 and 0.21. Okay, well that's this 1 here. So this must be the smallest number. So we've used that one now. So essentially you look for the smallest number going from left to right. And if there's a match, you then move on to the next number. And if there's a match, you move on to the next number until you find one which is uniquely the smallest. So again, for this case, we look for the smallest number here. Okay, that's 0. And there's no conflict. There's only one of those. So this is the next smallest number. Now let's go again. What's the smallest number here? Okay, they're both 1. So let's move on. Smallest number here, this one with a 0. So we put in 1.02. And last but not least, our final number, 1.20. And for a correct list, we get 1 mark. Simplify m plus m plus m plus m. So here we're going to collect like terms. Well, they're all like terms. They're all m. So how many m's have we got? We got 1, 2, 3, 4. So altogether, that gives us 4m, giving us 1 mark. And for part B, okay, so we've got 12p divided by 4. Now another way we can write this divided symbol here is we can write it as a fraction. So we're going to look at the left-hand side, and this is going to be the numerator. And the right-hand side is the denominator, so we're going to have it over 4. So essentially our task now is to simplify this fraction. Now looking at common factors, both in the denominator and the numerator, I can see that the highest common factor is 4. So if I divide the top by 4 and divide the bottom by 4, on the top we're going to get 12 divided by 4, which is 3. Then we've still got our p there. And then we've got 4 divided by 4, which is just 1. Now any fraction over 1, we can essentially ignore that. So we just take the numerator. So the answer here is 3p. And for that we get another mark. The diagram shows a rectangle, and we can see that rectangle here. And on the centimetre grid below, we need to draw an accurate scale drawing of the rectangle, using a scale of 1 centimetre representing 5 metres. So we've been told that the grid is a centimetre grid. So the lengths of these squares here are 1 centimetre. So let's firstly look at the 20 metres here. So again, we're going to go back to the fact that 1 centimetre equals 5 metres. Now I'm going to treat this a bit like an equation. I want to get to 20 metres, so how do I do that? Well, on the right hand side, if we multiply by 4, that will get me to 20 metres. So let's also do that on the left hand side. So if we multiply by 4, we're going to have 4 centimetres. So we know that 20 metres is 4 centimetres. So if we use your ruler, I'm going to draw 4 centimetres, so down 4 of these boxes here. Now we're going to do our exact same for our 35 metres up here, so we want to find out what that is in centimetres on our scale. Again, our starting point is going to be that 1 centimetre is 5 metres. We want to get to 35, so to get 5 to 35, we're going to multiply by 7. And if we do that to the other side as well, multiply by 7, we get that 7 centimetres equals 35 metres. So again, grabbing our ruler, we're going to draw along 7 boxes. So 1, 2, 3, 4, 5, 6, 7. And now we just need to complete it up so it's an actual rectangle. We get our first mark up here for realising that the sides are 4 centimetres and 7 centimetres on our scale diagram. And we get our second mark for correctly using that to draw the rectangle. Here's a list of whole numbers from 21 to 30. And in part A, from the list, we need to write down a square number. So square number is essentially when you've got any number multiplied by itself, this is the square number result. So we get a square number when it can be made up by a number that is multiplied by itself. And this is something that's great to learn. It's great to learn what some of the square numbers are. And if we have a look through, we can see here that 25 is a square number, because 25 can be made up by 5 times 5. It's 5 squared, which is 25. So 25 is the correct answer for 1 mark. Now part B says from the list we need to write down a multiple of 8. So this is going to be any number in the 8 times table. So now the 8 times table, if I write it out, we've got 8, 16, 24, 32. And I can stop there because our list only goes from 21 to 30. So we'll have a look if any of the numbers in our list up here matches down here. We see, oh, the number 24 does. So the answer is 24 for 1 mark. A baker has 3 bags of flour. Bag A and B contain the same amount of flour, and bag C contains 940 grams of flour. And in the 3 bags, there's a total of 2,500 grams of flour. And we need to work out the amount of flour in bag A. Okay, so I'm going to focus in on this line first. So we're told that bag A and B contain the same amount of flour. So I'm going to say bag A equals bag B. Now this line, bag C, contains 940 grams of flour. So I can directly write C is equal to 940. And now this line, we can see that in 3 bags, the total is 2,500 grams. So I can write A plus B plus C equals 2,500 grams. Now I'm going to use the facts up here to transform it. So since we already know that C is 940, I'm going to replace that. So we've now got A plus B plus 940 equals 2,500. Now for the next bit, we're going to use the fact that A equals B. So with this, I could either replace B with A or A with B. However, we want to work out the amount of flour in bag A, so I want to keep A here as a variable. So I'm going to replace B with A. So what I now get is A plus 940 equals 2,500. This is fantastic. So what we've now got is an equation which has one unknown, which is A. So we can solve to work out its value. So cleaning up the equation a little bit, we've got 2A plus 940 equals 2,500. Now if I subtract 940 from both sides, we're going to get that 2A is 1,560. Now I'm going to divide both sides by 2. So if I divide this side by 2 and this side as well, we're going to be left with A by itself on the left hand side, which is what we want, and 780 on the right hand side. And now we're done, we've worked out what the value of A is. So our answer is 780 grams. So we got our first mark here for this first bit of our manipulation of the equation. So subtracting 940 from both sides. We got our second mark for dividing by 2 to get A by itself. And the third and final mark if we get the correct answer of 780. 5 students throw a dice. They each throw the dice the same number of times. The diagram gives information about the number of times the dice lands on each number. So we can see that 1 has been landed on 6 times, 2, 4, and so on. And we need to work out the number of times each student throws a dice. So the first thing we're going to do is find out how many times the dice is rolled in total. So to do this, we're going to add up the frequencies. So now 1 was rolled 6 times. So we're going to do 6 plus 4 plus 5 plus 8 plus 7 plus 5. And in total, that gives us 35. So between the 5 students, the dice is rolled 35 times. However, it says in the question that they each throw the dice the same number of times. That means that each student rolls the dice 35, which is the total overall number of times the dice is rolled, divided by the 5 students, which equals 7. So each student rolls the dice 7 times. So you get 1 mark here for adding up to get the total, a second mark for trying to divide between the 5 people, and the final mark if we get the correct answer of 7. Alec needs to work out the value of 2 plus 3 multiplied by 4, and he writes that 2 plus 3 equals 5, and 5 multiplied by 4 is 20, so 2 plus 3 multiplied by 4 equals 20. But Alec's wrong, so we need to explain why. So the reason is that the order of operations is wrong. We actually need to carry out the multiplication first before the addition. What Alec's done here is he's done the addition then the multiplication. So we've done 3 plus 2 is 5. Okay, and then we're going to do the multiplication. We're going to do 5 multiplied by 4. So if we imagine brackets, this is what he did. He did 2 plus 3 first. However, we need to do it as if the brackets were like this. We need to do 3 multiplied by 4 first. So you might have heard of this before as either BIDMAS or BODMAS. So essentially we can see here that multiplication comes before addition. So working out what the answer actually is, we're going to do 2 plus I'm going to do 3 multiplied by 4 first. So I'm going to put it in brackets to show that's what we're doing. So if we do 3 multiplied by 4, that gets 12. So it's going to be 2 plus 12, which equals 14. And for that, we get 1 mark. So we could either say that the order of operations is wrong, or we could show that Alec got it wrong by showing what the actual answer is. So either of the options will get you the mark. Write 17 as a fraction of 30. So when we're writing something as a fraction of something else, we write it like this. The answer is going to be 17 over 30. So 17 is being written as a fraction of 30. So we're putting 30 here on the denominator. And for that, we get 1 mark. Reflect shape A in the mirror line. So the way I'm going to do it is I'm going to look at each vertex here and reflect those points, and then I can join up the shape on the other side. So if I take this point here, for example, to get to the mirror line, I move 1, 2 spaces. So I'm going to do the same here. I'm going to move 1, 2 spaces, and I'm going to plot that point here. Now for the next point here, I move 1, 2, 3 spaces to the mirror line. So if I move 1, 2, 3, I get to here. Last but not least, this one, we move 1, 2, 3, 4 spaces. So if we go 1, 2, 3, 4, and I plot it down here. So now the last thing to do is use a ruler to join up the shape. And if you carry out the correct reflection in the correct mirror line, we get 2 marks. Work out the square roots of 13.82 divided by 4.06, writing down all the figures on our calculator display. So your calculator might look slightly different, but the idea should be the same. First, going to click a button which should look like this for a square root, and then a fraction button, something like this. Now I'm going to use the arrows to make sure I select the top of the fraction and enter 13.82. I'm then going to select the bottom of the fraction and do 4.06. If I press equals, I should now get this on the calculator display. So if we write down everything we saw on our calculator, we'll get 1.844977205. And doing that will give us 2 marks. Now part B wants us to give the answer to part A to 2 decimal places. So to do this, from the decimal point, I'm going to count 1, 2. Then I'm going to look at the number after the second one. If this is 5 or higher, I'm going to round up. Or if it's less than 5, I'm going to keep it the same. This number is less than 5, so I keep this number the same. And rounded to 2 decimal places, we're going to have 1.84. And that gives us another mark. RST is a straight line. And in part 1, we need to work out the value of x. So to do this question, we need to remember that angles in a straight line add to 180 degrees. So looking up at our little diagram up here, we can see that would mean if we add x, 75 and 84, that would equal 180. So I can write that out as an equation down here. We're going to have x plus 75 plus 84 is 180. Now this is great because what we have here is an equation which we can solve to work out the value of x. So first, if I subtract 75 from both sides, we're left with x. This 75, take away the 75, we just get 0. So we can skip on to having 84 here. And on the right hand side, 180 minus 75 is 105. Now we can use the same trick again. If we subtract 84 from both sides, we'll be left with x by itself on the left hand side and 21 on the right hand side. So value of x is 21. And we get 1 mark for our working here and 1 mark for the final answer of 21. Now for part 2, we need to give a reason for our answer. And essentially, we already did this when completing the first part. Our answer is this, and it would probably be better for me to word it angles on a straight line. And for that statement, you get 1 mark. Write the following fractions in order of size, starting with the smallest fraction. So it's quite hard to tell which is smaller and which is bigger just by looking at the fractions. However, it's much easier for us to compare them if we convert them into another form. So we can convert them into decimals or percentages or something like that. So let's start by converting to decimals. Now this is a calculator paper, so to do that, we can put in the fraction 5 over 8 on our calculator and click equals. And there's a button which might look something like this in your calculator that will display the answer as a decimal. So if we click that, we'll see here that we get it 0.625. Now doing that for this one as well, if we put 2 over 3 in the calculator, click equals, then press the S to D button, that gives us 0.6 reoccurring. And then I've done the exact same thing with the other 2 fractions here. So what we've done in this step is we've converted to decimals. Now you might be able to just look at that and see which is the biggest and which is the smallest and put them in order. If so, that's great. But what I find sometimes a bit easier is if we now convert into a percentage. So to do that, if we multiply a decimal by 100, and I'm going to keep everything to 1 decimal place. So we're going to have 62.5. Now for the next one, we've got 0.6 reoccurring. So if I multiply that by 100, I get 66.6 reoccurring. So if I round that to one decimal place, we're going to get 66.7. Same for this one, I'm going to get 44. It's going to be 0.444444. So if we round that to one decimal place, it'll be just 0.4. And for the last one, we just get 60%. And now we should be able to order them much more easily. So we can see the smallest one is 44.4. And then the next one up is this one, 60%. Then this one, 62. Last but not least, 66.7. So I'm going to write it in that order, but referring to the fractions up here. So we'll have 4 over 9, 3 over 5, 5 over 8, and 2 out of 3. So we get our first mark for a conversion, so either converting to decimal or percentage, or both. And then we get our second mark if we then list the fractions in the correct order. The pie chart gives information about the colour of each car within the car park. We're told that there are 135 black cars in the car park. So part A says we need to work out the number of white cars in the car park. We know in the black section there are 135 cars. And we want to work out the number of white cars. And we don't know the number of other colours. So now we're going to look at the angles in the pie chart. So in the black section here, we can see it's 90 degrees. Because this symbol here means 90 degrees. So I can say that 90 degrees equals 135 cars. Now if I divide both sides by 90, I'll get that 1 degree is equal to 1.5 cars. So we'll work out the number of white cars in the car park. And we can see that that's represented by 80 degrees. So getting from 1 degree to 80 degrees, we're going to multiply by 80. So if we do that to this side as well. So 80 degrees is 120 cars. And that's our final answer, 120 white cars in the car park. So in the mark scheme, we get 2 marks here for our working. Then we get our third and final mark for the correct answer, 120. We're now told that there are 50 grey cars in the car park. And a car in the car park is picked at random. So we need to find the probability that the car is grey. So from part A, we know there are 135 black cars and 120 white cars. And from part B, now we know there are 50 grey cars. So if you remember from part A, we had that 90 degrees is 135 cars. Now to get the total, we're thinking about a pie chart. So in a pie chart, the total is going to be 360 degrees. So to get to 360 from 90, we multiply by 4. So doing that to this side as well, we're going to get 540. So that means that there are 540 total cars. So to get the probability that the car is grey, we need to take the number of grey cars, so that's 50. And we're going to divide that by how many cars there are in total, so 540. Now we've got the probability. And now we could simplify this fraction down further if we wanted, but we don't actually need to. So we can just leave that as the final answer. So we got our first mark for working out what the total number of cars are, and the second mark for the correct probability. Nazima uses this graph to find out how much money she has paid for the number of hours she has worked. Part A says how much money is Nazima paid for each hour she works. We can see that the amount goes up linearly, because our graph is a straight line here. So essentially the amount of money she has paid for each hour she works, we can work out how much she gets for 1 hour of work. So to do that, we look along our hours worked axis here, and we're looking for 1 hour. So we're going to have a look here. And grabbing our ruler, I'm going to draw a line up from 1 there until it hits our line. And then we're going to draw across from there. Now reading off on our pay axis here. So each of these boxes are going up in 2. So it's going to be 12, 14, 16, 18, 20. So we're going from 10, 12, 14, 16. This is halfway between that, so it's going to be 15. So she's getting paid £15 for 1 hour of work. And that is our final answer for 1 mark. Part B says Nazima worked for 36 hours. So we need to work out how much she was paid. So in the previous part, we worked out that 1 hour of work is equal to £15. So for 36 hours, if we multiply this side by 36, we're going to get 36 hours of work. And essentially, we're just scaling it up. So I can do this to the other side as well. I'm going to multiply by 36, which gives 540. So now it says that 36 hours of work is £540, which is the correct answer. Okay, so we got our first mark here for our working out, and our second mark for the correct answer. 60 people are asked if they prefer to text or email their friends. 38 of the people are women, and the rest are men. 15 of the men prefer to email them their friends, and 6% of the people prefer to text their friends. Complete the frequency tree for this information. Okay, let's unpack this a little bit more. 38 of the people are women, and the rest are men. Well, we know there are 60 people in total, so we can work out how many men there are. So if I do 60, I'm going to take away 38. That gives us 22 men. Now next, 60% of the people prefer to text their friends. So how many people is that? Well, in total, there are 60 people. And to get 60%, we need to multiply by 0.6. And that gives us 36. Great, so we've got all this information. Now let's complete the frequency tree. So we started with 60, that's all the people. Now we were told in the question there were 38 women. And then we worked out there were 22 men. And we're told in the question as well that 15 of the men prefer to email their friends. So we can fill that in here. Now for this box here, we know the choice they had was either between text and email. So we've got 22 men in total. 15 chose email, so I'm going to take that away, leaving us with 7 choosing text. Now we worked out that 36 people prefer to text their friends. So we can now fill in this box. If we know in total, including the men and women, there are 36 people that prefer to text. We worked out that 7 of them were men, so we're going to take away 7. We're going to be left with 29. Now lastly, we've got the email box here, and we do that in a similar way to all the others. We know there are 38 women in total, and we just worked out that 29 of them prefer to text. That leaves us with 9 left over, so there must be 9 women that prefer email. So we get our first mark for working out the 22 men here. We get the second mark for working out that 36 people prefer to text their friends. Then we get our final 3 marks for a correct frequency tree. The incomplete table gives some information about the lengths of planks of wood in Ben's workshop. The total length of these planks is 92 metres, and our task is to work out the number of planks of length 2 metres in Ben's workshop. Okay, so this is the box here that hasn't been filled in. This is what we're trying to work out. Now I'm going to give this a name. I'm just going to call it X. Now I'm going to do another column called total length, and this is going to be the length multiplied by the number. For example, here we're going to do 3 multiplied by 5. And we're doing that because here we've got the length of planks, so length of one of the planks is 3 metres. And here's the number of planks we've got. But we want to know how many metres that is in total. So imagine I've got 5 planks of length 3 metres, and I lay them out one in front of the other. How many metres will that be? Well, it's going to be 5 multiplied by 3, which is 15 metres. So I'm going to do that for the rest. So it's going to be 2.5 multiplied by 8, which is 20 metres. Now here, we're not sure what x is, so I'm just going to write 2x as our total length. And next we've got 1.5 multiplied by 14, giving us 21 metres. And last but not least, 1 multiplied by 10, giving 10 metres. So what's the total length that we've got? Well, we're going to add up 15, 20, 2x, 21 metres and 10. So I'm going to add up the totals. So if I do 15 plus 20 plus 21 plus 10 gives us 66. And you might notice I missed out the 2x. So we're going to have to add on 2x. Now if we bring that down here, we're told in the question that the length of these planks in total is 92 metres. So I can form an equation by saying 66 plus 2x equals our total of 92. So if I subtract 66 from both sides, we're going to get that 2x equals 26. And now I'm going to divide 2 from both sides. This 2 and this 2 cancel, leaving us with x. And 26 divided by 2 is 13. So that's the final answer. There are 13 2-metre planks. So we get 1 mark for what we did up here. So essentially getting down to where we created an equation. Second mark here for attempting to solve the equation. And the third and final mark if we got the correct answer of 13. Rachel, Samina and Tom share £600 between them. Rachel gets 2/5 of the £600. Samina gets 1/4 of the money left over. Tom gets the rest of the money. Tom says, I would have got more money if we had shared the £600 equally between us. And we need to work out if Tom's correct or not. So starting off with this line here, Rachel gets 2/5 of the £600. Well, if we do 600 multiplied by 2/5, that gives £240. Now, Samina gets 1/4 of the money that's left over. We know that in total there's £600, and because Rachel got 240, so that gives us £360. And in the same way that we did before, Samina's getting 1/4 of this money. So we're going to do 360 multiplied by 1/4, giving them £90. So this is step 2. So we've used what we got in step 1 to work this out in step 2. Now step 3, we're going to work out how much money Tom gets. So Tom gets the rest of the money. So if we started off with 600, and then we took away the 240 that Rachel got, and the £19 that Samina got, that leaves Tom with £270. So now if everything was shared equally, Tom would get, okay, so we're going to have 600 in total. And if it's shared equally between the 3 of them, we'll divide that by 3. so £200. Now Tom said that he would have got more money if the money was shared equally between them. So for our conclusion, we need to say Tom is not correct in saying that. Since if it was shared equally, he would have got £200. But actually, how it was shared, he got £270. Meaning if it was shared equally, he would have actually got less money. And we get a mark here for each of these steps. And then a final concluding statement here, saying that Tom's not correct and explaining why. Part A says we need to simplify c to the power of 5 divided by c to the power of 2. Okay, so another way to write this division sign, so we can write it like a fraction. So I'm going to write c to the power of 5 over c to the power of 2. Now let's imagine that I've got x to the power of a, and that's divided by x to the power of b. That's going to equal x to the power of a minus b. So when we're dividing like this, as long as we've got the same base, so I've got x here and x here, our result will be this base, so x, and then we take the indices and subtract the one on the denominator from the one on the numerator, so we get a minus b here. So doing the same thing for our example here, we're going to have c, because we can see we've got c here and c here, and then we've got 5 and 2, so it's going to be to the power of 5 minus 2, which equals c to the power of 3. And if we get c to the power of 3, we get 1 mark. Now for part B, we need to simplify d to the power of 4 all to the power of 3. Okay, so I'm going to do a general example again using x. So if we have x to the power of a and all of that to the power of b, that's going to equal the same as x to the power of a multiplied by b. So in my case, I've got d to the power of 4, and that's all to the power of 3. So that's going to equal d to the power of 4 multiplied by 3, so d to the power of 12. And again, that gets us 1 mark. Part A says write down the inequality shown on this number line. So we can see we're going from -1 and then we're going all the way up. And now since this number line is referring to x, we can say that x is going to be greater than -1. Now something we need to consider, is it greater than like this, or is it greater than equal to? And in this case, it's going to be greater than like this. We got to look up at this circle here. So if the circle's not filled in like this, we know that it's either greater than or less than, but it's not greater than or equal to or less than or equal to. So that's why in this case, greater than -1, however not equal to -1, because this circle on -1 is not filled in. And for that we get our 1 mark. Now for part B, we need to, on the number line, show the inequality y is greater than or equal to -3 and less than 4. So let's find -3 here and 4 up here. So it's going to be greater than or equal to -3. So we need to do our circle here, but we need to fill it in, because that essentially says that it could also be equal to -3. You can see that it's less than -4, not less than or equal to, because we don't have an extra line here. So I'm going to do my circle, but I'm not going to fill it in. And then our last step is to join it all up. So from less than -4 to greater than or equal to -3. And if we do that, we get 2 marks. Find the highest common factor of 60 and 84. So the first thing we're going to do is make a factor tree for 60 and 84. So what I mean by that is I'm going to start with 60 and we're going to branch off and look at some factors. So what two numbers multiply together to get 60? Well, we can get 2 and 30 would work. And as soon as we reach a prime number, we know that branch has stopped. So here we can see 2 is a prime number. So this branch has stopped and I'm going to put a circle around it. But because 30 isn't a prime number, this branch is going to carry on. Okay, so factors of 30. Okay, we could have 2 again and 15. Cool, so this branch has stopped because we got a prime number. But 15 we can carry on. So we can have 3 and 5 there, because 3 multiplied by 5 gives us 15. And now both of these are prime numbers, so we'll circle them. And we see we've got no branches to carry on, so we're all done. Now let's do the same thing for 84 over here. I'm going to split that off into 2 and 42. So we're going to circle the 2 here. And 42, okay, well, we can split that into 2 and 21. And lastly, we'll get 3 and 7, which are both prime. So we're done. So what this tree has told us is that 60 is made up by multiplying 3, 5, 2, and 2. And the same way for 84, it's made up of 7, 3, 2, and 2. So now to get the highest common factor, we're going to work out what is common in each prime factorization. So you see we've got a 2 here, And if I've found it in 60, I need to look, is it in 84? Yeah, so I'll cross that off. So for our highest common factor of 60 and 84, we're going to have a 2 in there. Now we see, oh, we've got another 2 here that's common to both of them. So we're going to multiply by 2 again. And I can see, well, I've got 3 here and 3 here. So we can multiply by 3. However, I can't do anything with this 5 because that's only in this prime factorization, not over here. And there's only a 7 here, not up here. So now we're done. So we've got 2 multiplied by 2 multiplied by 3, which equals 12, which is the final answer. So we get our first mark up here for our factor trees, and our second mark for the correct answer of 12. Now part B wants the lowest common multiple of 24 and 40. So again, for this question, we want to create our factor trees. So starting with 24, we can split that off into 2 multiplied by 12, and 6 multiplied by 2, and 3 multiplied by 2. Now one thing I just want to point out is you can split it up however you want. We can split here as 2 and 20, because 2 multiplied by 20 is 40. However, you might also be thinking, we could split up as 4 and 10, and that's absolutely fine. We'll end up at the same point however you split it up, so just split it up however's easiest for you. So now in this case, we're going to have 2 and 2, and 2 and 5. So now we need to work out the highest common factor first in the same way we did before. So I've written out our prime factorizations. So the highest common factor of 40 and 24, we're going to look for our pairs. So I've got 2 here and here. So we've got a 2, 2 here, 2 here, and 2 here, 2 here. So it's going to be multiplied by 2, multiplied by 2. And that's it, because we haven't got any more pairs out of these numbers. Meaning our highest common factor is 8. Now the lowest common multiple of 40 and 24 equals our highest common factor, which is 8, multiplied by the numbers we had left. So multiplied by 3 and multiplied by 5. And doing that, we get 120. So again, our first mark comes from the factor trees up here, and the second mark for the final answer of 120. Sam drives his car on a journey. Here is the travel graph for the first 15 minutes of his journey. So we've got the time of day on this axis and the distance travelled in kilometres on this axis. And in part A, we need to work out Sam's speed in kilometres per hour for the first 15 minutes of his journey. Okay, so this is the first 15 minutes of his journey because we're going from 0 up until halfway between 10 past and 20 past. So essentially, we need to work out the speed represented by this line here. Now what we have here is a distance time graph because we're plotting the distance and the time. Now when we've got a distance time graph, we need to find the gradient of the line to work out the speed. So now the gradient of a line is worked out by the change in y divided by the change in x. So for the change in y, we're going from 0 kilometres up to 20 kilometres. So it's going to be 20 minus 0 kilometres. Divided by, okay, change of x, we're going from 10 o'clock to 10:15. So the change there is 15 minutes. So that's going to equal 20 over 15. However, we've got kilometres and minutes. So units here is kilometre per minute rather than kilometres an hour. We want kilometres per hour. So to do that, we're going to multiply by 60. So that gives us 20 over 15. Multiply by 60, which gives us 80 kilometres an hour, which is the final answer. So we get 1 mark here for our method, and 1 mark here for the correct answer of 80 kilometres per hour. At 10:15, Sam stops for 10 minutes, and then drives for 20 minutes at speed of 75 kilometres per hour. So on the grid, we need to complete the travel graph of Sam's journey. Okay, so we know that for the first 15 minutes, Sam's travelling. And then at 10:15 here, Sam's stopping for 10 minutes. Well, what does it mean to be stopped? Well, that means to be going 0 speed. Well, we're looking at a distance time graph, so speed is represented by the gradient of the line. So essentially, to stop means that the gradient needs to be 0. And for the gradient to be 0, that's just a horizontal straight line like this. So we need to draw that on for 10 minutes. So going from 10:15, 10 minutes from there is going to be to 10:25. So I'm going to draw on a straight line to there. Now for the next 20 minutes, we want to be driving at a speed of 75 kilometers per hour. Distance equals speed multiplied by time. However, for this to work, we need everything to be consistent, so we need to either be in hours and hours or minutes and minutes. However, we're not consistent at the minute. We're talking about travelling for 20 minutes at a speed of 75 kilometers per hour. So what we need to do is convert 20 minutes into hours, which is 20 divided by 60. I'll simplify that down, 1 over 3 hours. So now we can use this. I'm going to have the distance is speed, which we've got as 75 kilometers per hour, multiplied by time, which is 1/3 of an hour. And this gives us a distance of 25 kilometers. So we're now going to plot this onto the graph. So this is for 20 minutes. So we're going from 10:25 to 10:45. And we know between here and here, we're travelling 25 kilometres. So starting at 20, we're going to do 20 plus 25, giving us 45. So our line is going to go like this, up to 45 here. We get 1 mark here for this straight line portion here. Another mark for working out the distance of 25 kilometres. And a third mark for this portion of the graph here. Complete the table of values for y equals x squared minus 2x plus 2. So the way we do this is we take our x value, we sub it into the right hand side of the equation, so replacing x with the value in the table, and then whatever we get for y we put in this part of the table. We'll take a look at this box for an example. We sub in x as minus 2, and if we work that out we get the value of y to equal 10, so 10 is put in the table here. So we have to do that for our missing spaces in the table. So here we're going to get y equals minus 1 squared minus 2 minus 1 plus 2, giving us 5. Here we're going to get y equals 1 squared minus 2, 1 plus 2, giving us 1. So here we got y equals 2 squared minus 2, 2 plus 2, giving a value of 2. And last but not least, y equals 4 squared minus 2, 4 plus 2, giving a value of 10. And if you get all of those values correct, you get 2 marks. Part B says, on the grid, draw the graph of y equals x squared minus 2x plus 2 for values for x from minus 2 to 4. Okay, so that follows on really nicely from the first part. In our table from the first part, we were completing it for the same quadratic here, and we were going between x's minus 2 and 4. So we know the corresponding y value for each x value, so we can use these as pairs of points and plot them on the grid below. So when x is minus 2, y is 10. The next one, x is minus 1, y is 5. So going along minus 1 here, all the way up to 5. X is 0, y is 2. Well, x is 1, y is 1. It's going to be 1 along here and up to 1 here. And x is 2, y is 2. So up here, x is 3, y is 5. And x is 4, y is 10. So you see we've got a basis of a nice quadratic shape here. And lastly, we've got to try our best to join it up. And if we do that, we get 2 marks. And on the final part says, use your graph to find estimates to the solutions of the equation x squared minus 2x plus 2 equals 4. Okay, so from this, we can split that up to say, okay, we've got y equals x squared minus 2x plus 2, and y equals 4. So our solutions, when we equate these, essentially, so saying x squared minus 2x plus 2 equals 4. So then we've got the graph of this plotted, so now I'm going to plot this. So plotting y equals 4, on the y-axis, let's look for 4, and that's going to be a straight line across here. Now we need to look at the points of intersection, so here and here, and work out the x values. So for this point of intersection here, we're going to go down and see the value on the x-axis, and same for this point of intersection here. This is 2.5, so this is going to be 2.6, 2.7. And over here, this is going to be minus 0.5, so minus 0.6, minus 0.7, minus 0.8. So our answers are that x equals minus 0.8 and x equals 2.7. And we get 1 mark for each of those. So you get the marks if you're anywhere between minus 0.65 and minus 0.8, and 2.65 and 2.8. So you've got a little bit of leeway, so you don't need to worry too much. Here is a right angle triangle. The shape below is made up from 2 of these triangles, and our task is to work out the perimeter of the shaded shape, giving our answer to 3 significant figures. So what I can see here is I've got a right angle triangle and I know 2 of the sides. This means I can use Pythagoras' theorem to work out the missing side. So Pythagoras' theorem says that a squared plus b squared equals c squared, where c is always the hypotenuse, so that's going to be this side here. And then a and b can be either of the other ones, so I'm going to say this one's a and this one's b. So using this, we're going to have 10 squared, because a is equal to 10, plus 8 squared, because b is equal to 8, equals c squared. So working this out in the calculator, we're going to get that c squared equals 164. To get c, we're going to square root both sides, and that's going to give us plus or minus the square root of 164, which is going to be plus or minus 2 the square root of 41. Now you might notice we've got 2 solutions. We've got plus 2 root 41 and minus 2 root 41. However, we can ignore the negative since we can't have negative length, because we said at the start that c is going to be this length here, which means our final answer is that c is 2 square root of 41. Now we're told that the shaded shape below is made of 2 of these triangles. Now these triangles are identical to the one above, so we can fill in the missing lengths. So this shorter length here this is the base of our right angle triangle, and we know that that's 10 millimeters. Now we just worked out the hypotenuse, that is going to be 2 root 41. Now this is our other triangle here, so this whole thing, not just this small part, this whole length here, is going to be the hypotenuse, so that's also 2 root 41. So this part here is going to be the length of this whole thing here, so 2 root 41. And we're going to subtract this part here, so 10 millimeters. So this yellow bit here is 10 millimeters, and this green bit is 2 root 41 minus 10 millimeters. So now we've got enough to work out the perimeter. The perimeter is going to be 10 plus 8 plus 8 plus 2 root 41 plus 2 root 41 minus 10. We get 41.61249 ... and you'll have even more numbers on your calculator. However, we want that to 3 significant figures. So the answer is going to be 41.6. 3 significant figures. We get our first mark for realising we need to use Pythagoras and getting the value of c squared. We got our second mark for then getting the value of c. We got our fourth mark down here for working out the perimeter. And the fifth and final mark if we get it correct to 3 significant figures. ABC is a right angle triangle. And in part A we need to work out the length of BC, giving our answer correct to 1 decimal place. So we're trying to work out this length here. So to do this we can use trigonometry. So we've got this little helpful reminder here, SOHCAHTOA. I'm going to use that in a second. Now the first thing I need to do is label the sides. So we've got a right angle triangle, and we've also got one known angle. Whichever side is connected to the right angle and the angle we know, we can label as the adjacent side. The side that's opposite the angle that we know is the opposite side, so we're going to label it as an O. And the side that's opposite the right angle is the hypotenuse, so we're going to label that H. Now this side here is the one I want to work out. So we're going to look at SOHCAHTOA here and see what we can do to work out this length that we want to find out. So we know it's got to include an O, so we can ignore this part here. So it's either going to be sine or tan. So we need to look about what we have information about. We have information about the adjacent, but not the hypotenuse. So we can't go with sine because that would have two unknowns, the opposite and the hypotenuse. So we're going to have to go for tan. And what this essentially means is we've got tan of some angle is going to equal the opposite over the adjacent. So in our case, we got tan of 56 degrees equals opposite, because we don't know that yet, over adjacent, which is 12. Well, what is the opposite side? That is the length that we want to work out, BC. Now, if I multiply both sides by 12, I'm going to have 12 tan of 56 degrees equals the length BC. So if I put all of this into the calculator, I'm going to get that BC equals 17.79073 ... But we want that to 1 decimal place, so that's going to be 17.8. So the final answer here is 17.8. So we get 1 mark for our working over here, and 1 mark for the correct final answer to 1 decimal place. Now for part B, we're told that PQR is a right angle triangle. And we need to work out the size of the angle marked X, giving your answer correct to 1 decimal place. So again, we're going to use trigonometry. And again, we can use SOHCAHTOA to help us. But this time, instead of working out the length of a side, we're working out the size of an angle. So again, step 1 is to label A, O, and H. So the one that's connected to the angle and the right angle is the adjacent side, so A. The side that's opposite the angle is opposite. And the last one here is the hypotenuse. So what information do we know? Well, we've got some information for the adjacent and for the hypotenuse. So this means we have to use cos, because that uses our information for the adjacent and hypotenuse. So what this means is that cos of some angle is the adjacent over the hypotenuse. So in our case, we're going to have cos of our angle x. It's going to equal the adjacent over hypotenuse, so 15 over 18. Now to get this x by itself, we can do inverse cos. So we say x equals inverse cos of 15 over 18. And if we put this into the calculator, we get 33.5573 ... However, again, we want 1 decimal place, so that's going to be 33.6 degrees to 1 decimal place. So the final answer is 33.6 degrees. And again, we're going to get 1 mark here for working, and 1 mark for the correct final answer to 1 decimal place. Solve x squared minus 7x minus 18 equals 0. So there are a number of different methods we can use to solve a quadratic, but I'm going to do this by factorising. So essentially that means I'm going to take this quadratic and I'm going to put it into a pair of brackets. So I'm going to have a bracket here multiplied by another bracket equals 0. So we need to work out what set of brackets would multiply out to give us this expression here. So firstly, let's look at the x term. We're going to have x squared. So I know I must have an x here and x here. Because when I multiply out the brackets, I want to have x multiplied by x giving me x squared. Now for the second terms in the brackets, we need them to multiply to create this term here, so minus 18. And we need them to add to give us the coefficient of this term, so minus 7. So again, we need them to multiply to minus 18 and add to minus 7. So I'm just going to brainstorm some pairs of numbers. If I have minus 18 and 1, so that multiplies to minus 18. However, it doesn't add to minus 7. I have that the other way around, but again, that doesn't add to minus 7. I could have 9 and minus 2. So we know that this pair won't work and this pair won't work. However, with this one, if we do 9 multiplied by minus 2, we're going to get minus 18. So that's great, that's what we want. And 9 plus minus 2 is going to equal 9 minus 2, which equals 7. This won't work. So we can't do this because we need minus 7, not 7. So what we could try instead is the other way around. Let's do minus 9 and 2. If we have minus 9 multiplied by 2, we get our minus 18 again. So perfect. But this time, minus 9 plus 2 gives us minus 7, which is what we want. So this is the pair that we're going to go for. So filling in our brackets, we're going to have x minus 9 multiplied by x plus 2. Now we've got something multiplied by something is 0. Well, that means at least one of these brackets is going to be 0, because we know the only way to multiply something and get 0 is to multiply by 0. So we can say that x minus 9 has got to equal 0, or x plus 2 has got to equal 0. So if we solve this equation now, we're going to have x equals 9. If we solve the other one, we're going to have x equals minus 2. So those are our two solutions. X equals 9 and x equals minus 2. We get a mark here for our correct set of brackets. We get a mark here for the start of our working. And we get a final mark for the correct answer of x equals 9 and x equals minus 2. In a sale, the normal price of a boat is reduced by 15%. So this means that the sale price of the boat is £272,000. So what's the normal price of the boat? So essentially, we've got the normal price of the boat. It's been reduced by 15%, and that gives us this price, £272,000. But we want to work out what it was before it was reduced by 15%. I'm going to define a variable x, which is going to represent the normal, or you can think about it as the original price. And the price was reduced by 15%. So to do that, you multiply by 0.85. Let's think about this. If we multiply by 100%, or in decimal form, that's 1, then that's not going to make a difference. That's not giving any discount. However, we want to reduce by 15%. So that's going to be 1, so basically no reduction. And we're taking away 15%. So 15% in decimal form is 0.15. And that equals 0.85. So we've got the whole thing, and we're taking away 15%, which is why we multiply by 0.85. And we're told in the question that if we do that, we get a value of 272,000. So now we create an equation. If I write it a bit neater, we're going to have 0.85x is going to equal 272,000. So if I divide both sides by 0.85, 0.85 and 0.85 cancel, leaving us with x on the left-hand side. And on the right-hand side, we're going to get 320,000. And one thing we can check to make sure we're sort of on the right tracks is, do we want this number to be greater or less than this number? Well, we want it to be greater than this number, because this number was when there was a discount. So the original price must be greater, so we know we're on the right tracks. So normal price of the boat was 320,000. And we get one mark up here for our working, and the second and final mark for the correct answer.